What is a multimeter or multitester? A multimeter or multitester, also known as a voltometer, is an electronic measuring instrument that can measure multiple electrical properties. A typical multimeter can measure voltage, resistance, and current in electrical circuits. A multimeter can be a handheld device useful for basic fault finding and field service work, or a bench instrument which can measure to a very high degree of accuracy. They can be used to troubleshoot electrical problems in a wide array of industrial and household devices such as electronic equipment, motor controls, domestic appliances, power supplies, and wiring systems. There are primarily two types of multimeters based on their functionality and usage: the analog multimeter and digital multimeter. Analog multimeters have a needle or pointer that moves across a scale to indicate measurements and typically have a rotary dial to select the desired measurement. They are generally less expensive than digital multimeters and can be more durable in certain environments. Digital multimeters displays measurements as numerical digits on a digital screen and offer higher precision and accuracy compared to analog multimeters. They are suitable for precise measurements and are often preferred in professional environments where accuracy is crucial. This is the example of digital multimeter and analog multimeter. History of the multimeter. The first device that could be considered as a predecessor to the multimeter showed up in 1820. It was a moving pointer current detecting device called a galvanometer, designed only to detect electrical current and could make a compass needle move. The galvanometer was useful in the lab, but it was very bulky and impractical for fieldwork. In 1920, a British post office engineer, Donald McCady, is credited with inventing the very first multimeter. The story goes that he was frustrated that he needed to carry a bunch of different tools when working on telecom lines, so he created one tool that could measure amperes, volts, and ohms, leading to the product being named the avometer. It was comprised of a moving coil meter, voltage and precision, resistors and switches and sockets. Pocket watch style meters were also in widespread use in the 1920s. The metal case was typically connected to the negative connection, an arrangement that caused numerous electric shocks. The technical specifications of these devices were often crude and had limited functionality. In 1970, vacuum tube voltmeters or valve voltmeters were used for voltage measurements in electronic circuits where high input impedance was necessary. The vacuum tube voltmeter had a fixed input impedance of typically 1 megaohm or more, usually through use of a cathode follower input circuit. The Fluke 8020A digital multimeter was the world's first successful handheld digital multimeter. or a voltmeter with multimeter features. The Fluke 8020A digital multimeter made big news in 1977 because it proved to be highly accurate, reliable, easy to use, and very durable. Basic parts of a multimeter. Scale. This is how you read the value being measured. For an analog multitester, this is a series of markings in a semicircle. You can read different variations such as voltage, current, and resistance on the scale. Needle or pointer. This is the needle-shaped rod that moves over the scale of a meter. The needle pointer is mechanically connected to the moving coil. The value the pointer hovers over indicates the value being measured by the multitester. Note that when there are multiple values being measured on the same scale, you'll need to pay attention to which port the multitester is connected to. Match the port up with the value being measured. Adjustment screw. This part, which is also known as the dial or infinity knob, allows you to adjust the pointer to the zero position of the scale. This is usually accompanied with the help of a flathead screwdriver. It is good to know that the name infinity knob comes from the fact that at zero voltage you have infinite resistance. Zero ohm adjustment knob. The zero ohm adjustment knob is used to calibrate the multitester when you want to measure the resistance of an object. To make sure the multitester is calibrated correctly, you have to turn on the multitester. Then connect the metal tips of the two probes and finally use the zero ohm adjustment knob to use the needle to point to 0 ohms on the scale.
Range selector knob, also known as a selector switch. This allows you to adjust the settings of the multitester. Using this, you can change what the multitester is measuring as well as the range of the measurement. The range selector knob can be auto-ranging or manual ranging. Auto-ranging means it's much easier to work with. You simply adjust the dial to the symbol corresponding the electrical parameter you want to measure. You connect the test probes and you have your measurement. While manual ranging, on the other hand, is a little bit trickier. With manual ranging, you need to adjust the dial so that the value is set to is higher than the maximum value you expect from the circuit. Test probes. A test probe or a test lead is an instrument used to connect a multimeter to a device under test, which is known as DUT. Test probes are flexible insulated wires. They are able to establish an electrical connection between a multimeter and the DUT without exposing electrical workers to live conductive parts. Red test probes connect to the positive terminal and black test probes connect to the negative terminal. Ports. The holes at the front of the multimeter are known as ports. You need to plug your test probes into the appropriate ports to allow the multimeter to measure the parameter that you're interested in. There are three main parts on the front panel of a multimeter. First, COM symbolizes common and is usually used to connect the ground or negative part of the circuit. Next, it enables the measurement of voltage, current, and resistance. 10A is the special port used to measure large currents, typically greater than 200 mA. Common multimeter symbols. Voltage, also known as electrical potential difference, is the measure of the energy per unit charge that is transferred from one point to another in an electric circuit, usually denoted by a capital V. Voltage is what causes electric charges to flow in a circuit. It may have AC, alternating current, and DC, direct current voltage settings. Current, represented by the letter A, indicating the measurement of electric current flowing through a circuit, or in other words, it's the amount of charge passing through a particular area in a specific amount of time. It may have settings for measuring both AC and DC current. The unit for current is amperes or amps. Resistance. Resistance is the opposition to the flow of electric current in a circuit. It's measured in ohms. The diode test function looks like an arrow pointing towards the center of a plus sign. It is used to check whether a diode is working or not, while the capacitance function allows you to measure the capacitance of capacitors in an electrical circuit, and the temperature function measures the temperature of the circuit wires. General guide on how to use a multimeter. First, select the measurement function, turn the dial or press the appropriate buttons on the multimeter to select the desired measurement function. Common functions include voltage, current, resistance, capacitance, continuity, and diode testing. Next, set the range. Choose the appropriate measurement range for the parameter you are testing. For example, if you expect the voltage to be around 5 volts, select a range that includes these values such as 0 to 10 volts. Next, connect the test leads. For voltage, resistance, and continuity measurements, insert the black lead into the COM or common socket and the red lead into the voltage, resistance, and milliamp socket. For current measurements, insert the red lead into the 10A socket. Next, connect to the circuit. Ensure that the circuit is turned off and disconnected from the power source. Then connect the test leads to the appropriate points in the circuit. You want to measure for voltage measurements. Connect the leads in parallel with the component or points you want to measure. For current measurements, the multimeter must be connected in series with the circuit. Take the measurement. Turn on the multimeter and observe the reading on the display for voltage and resistance measurements. The display will show the value in volts or ohms. For current measurements, ensure that you have selected the appropriate range and that the multimeter is properly connected in series with the circuit. Interpret the reading. Once you have taken the measurement, interpret the reading to understand the status of the circuit or component you are testing. For example, a voltage reading of 5 volts indicates that there is a 5 volt potential difference between the points you are measuring. Multimeter do's and don'ts. Do's. Read the manual. Before using a multimeter, thoroughly read the user manual provided by the manufacturer. Different multimeters may have specific features and instructions. Inspect the multimeter. Check for any visible damage or defects before using the multimeter. Ensure that the probes are in good condition and not damaged. Select the appropriate range. When measuring voltage, current, or resistance, select the appropriate range on the multimeter to avoid overloading the instrument and obtaining inaccurate readings. Store properly. When not in use, store the multimeter in a safe and dry place, preferably in its protective case. Don't expect the maximum. Don't exceed the maximum ratings. Avoid exceeding the maximum voltage, current, or resistance rating specified for the multimeter. Doing so can damage the instrument and pose safety risks. Don't touch the probes during measurements. When taking measurements, avoid touching the metal probes to prevent electric shock or short circuits. Don't use damaged probes. If the probes are damaged or worn out, replace them before using the multimeter. Damaged probes can lead to inaccurate readings and unsafe conditions. Don't leave the multimeter unattended. When the multimeter is powered on, do not leave it unattended, especially in high voltage environments.